So this question is about inclined forces that are being pulled up a slope rather than the ones before they were just sliding down and there was no F app. So let's start with drawing our free body diagram. We have our incline and our object as usual. Now this one is a little different in the terms that now we do have an F app. Sometimes though we could refer to this as FT, but the tension of whatever is what's pulling it up, if it is a cable or whatever, it is F app. So whether you choose to say it's F app or FT, whatever, I'm going to refer to it as F app, okay, because it's the force applied. Doesn't matter if it's cable or a rope or whatever. I'm also going to put down the direction of motion, so D of M is going that way. All right, so now my definition of friction is that it's whatever is opposing the force applied. So now I have my FF I know I can draw. My FN is perpendicular to whatever surface I have, so I can draw my FN. And then I can also draw my FG, so that one's straight down. So again, just like the previous ones, we're going to split up our FG into perpendicular and parallel vectors. So we have our FG perpendicular and our FG parallel. And between FG parallel and perpendicular is a right angle. I know that mine probably maybe doesn't look exactly like a right angle, but we assume that FG and FG parallel and FG perpendicular are at right angles to each other. Okay, so then I can add in one more thing onto this diagram. I can add in that I do have FG parallel here. I just incorporate it into actually attaching that force to my object. So now I'm being asked to find the coefficient of friction. So what I'm going to start with is just writing out my F net for this equation. Now remember that when we're talking about these objects sliding down or being pulled up an incline, our F net is F net parallel, because our object is only moving parallel with the surface. So my F net is F net parallel. And please write in actually F net parallel and like FG parallel, etc., because else it gets too mixed up. There's too many FGs and F nets going everywhere. So if we are to find F net parallel, I'm going to set F app to like a positive value, because that's what's going in the direction of my motion. So I have F app. And then so FF is going to be negative, as well as FG, because they're opposing my direction of motion, FG parallel specifically. So I'm just going to rewrite this as F net parallel is equal to F app minus FF minus FG parallel. Then when I write it out like that, then I don't have to worry about, is FF negative, is FG negative? It's just already incorporated into my equation. Okay, so now I'm just going to think and identify, I'm being asked to find coefficient of friction. So I need to find and use my FF. Well, let's see, my F app, I can find, I put this all down everywhere. Oh, I'm already given F app, right? 46 newtons. My FG I can find using trig. And my F net parallel I find going M times A. So sometimes I just kind of write out all that information just to see, okay, what do I know, what don't I need to know, because there's often several steps involved with these problems. So I need to find a lot of things. So what I'm going to do first is I know that I need to find out, to find my FF, because I'm not given any other stuff about it. To find the coefficient of friction, I have to use the formula FF is equal to mu Fn. So once I find this FF, I need to apply it to this problem. So what I wrote down on my paper is I'm going to use horizontal info to find my FF. Just like when we did the force of friction from the very beginning, we divided it into horizontal and vertical information. And this Fn I find using vertical info. So I don't know about you, but this is how I like to do these problems, because I just kind of set up a roadmap of what I'm going to do in my question, because there's like 5 steps for the question, you know? Sometimes I get lost. So anyways, okay, so my vertical information. For my vertical information, Fnet of y is equal to Fn plus negative Fg perpendicular. This is Fnet perpendicular, or Fnet y, doesn't matter. So Fnet perpendicular, though, I can set to 0, because I know that the overall movement of my object is sliding down parallel. So Fnet perpendicular, who cares? So then I can say Fn is equal to Fg perpendicular. Well, now I need to do some trigonometry. So I'm going to redraw my triangle that I had drawn on my free body diagram. This is Fg perpendicular, and Fg parallel. So for my vertical information, I'm looking to find Fg parallel. Well, I can find my Fg. Oh, and I didn't write in my angle. I know this is 35 degrees based on the information it gave me at the beginning. And I'm just going to put a 1 here for step 1. So I can find my Fg by going m times g, which is 4.5 kilograms multiplied by 9.81 meters per second squared. So Fg is equal to 44.145 newtons. So for this question, I'm looking to find Fg perpendicular. So that is adjacent to my angle, and I can use my hypotenuse. So I need to use cos to find this. So Fg perpendicular is cos of 35 degrees is equal to Fg perpendicular over 44.145 newtons. You cross multiply to solve for Fg perpendicular, which is equal to 36.16 newtons. Am I going too fast, too slow? Any input there? Okay. So originally I said my Fn is equal to Fg perpendicular. So now I can set this to Fn. Okay, so one part of my problem is solved, because I knew I needed Fn. Now I need to solve for FF. So I'm going to use my Fnet equation and rearrange. So my FF is equal to FAP minus FG parallel minus Fnet parallel. I just rearranged that question, or that one. Okay. So now I can figure out these things. So I said my F app, I already know is 46 newtons. My FG parallel, I'm going to use trig. And my Fnet is M times A. So I'm just going to look back at my diagram and find FG parallel here. So FG parallel now is sine 35 degrees is equal to FG parallel divided by 44.145 newtons. So FG parallel is 25.32 newtons. So this is like step 2. Then I also need to find my Fnet parallel. I said is M times A. So that's 4.5 kilograms multiplied by 2.6 meters per second squared. So Fnet parallel is equal to 11.73 newtons. Okay, another part of my problem done. So now, using that information, I can find my FF. Great, finally. Oops. So FF is equal to 46 newtons minus 25.32 newtons minus 11.73 newtons. So FF is equal to 8.979 newtons. Okay, so I have my FF and I have my Fn. Now I can find my coefficient of friction. Do you need to see anything on the board, or can I scroll it all down? Lack of response means no. So FF is equal to mu Fn. This is what we've been waiting for. So now FF divided by Fn is equal to mu. So 8.979 newtons divided by 36.16 newtons is equal to mu. Mu is equal to 0.248. It doesn't have any units. We round to 2 sig digs. Now you can do question 2 on your assignment problem sheet. You can also do question 24 on your dynamics review. And you can also do textbook page 188, numbers 1 and 2 for practice.